Assume that a 59-gram ball traveling in the increasing x-axis at a speed of 33.4 meters per second bounces off an inclined plane in the positive y-axis direction at a speed of 2.9 meters per second in 37 milliseconds. Find the impulse applied on the ball by the wall. Find the average force applied by the wall on the ball. So as usual, first thing you should do is draw a little diagram explaining the problem. So here's our figure. So here's a ball traveling along the x-axis. It bounces off. It's traveling. The mass of the ball is 59 grams, which is converted into 5.9 times 10 to the minus 2 kilograms. And we're told that the initial, it bounces off of, let's see, ink-up line, positive y-axis speed. So traveling along the x-axis, bounces off and then bounces up. So let's say the initial velocity. So I'm taking I hat along the x-axis, j hat along the y-axis. So v initial and v final. V initial velocity vector happens to be 3.4 meters per second. I hat. Final velocity is equal to 2.9 meters per second. J hat. So the ball bounces off a plane, an inclined plane. We know that we're asked to find the total impulse I for the ball. On ball by the wall. So the impulse, so our whole idea is that the impulse I is equal to the total momentum after, or final momentum, minus the initial momentum before. So we can plug this in as mv final minus mv initial. So here's the ball, I called it B. So we can plug in numbers. So it's 59 grams, so it's 5.9 times 10 to the minus 2 kilograms. Standard units, kilogram meters in second. The final is 2.9 J minus 3.4 I hat. And we can just calculate, bring out a calculator. So let's do the I hat first. So 5.9 times 3.4. So 5.9 exponent to the 2 minus multiplied by 3.4 gives me 0.20. There's a minus in the I, so I'll put a minus over here, plus a j hat of 5.9 exponent to 2 minus multiplied by 2.9, 0.17. Impulse is going to be in units of momentum, which is going to be in, the whole thing will be in kilograms per meter per second, standard units. Or natural units are kilograms, meters, and seconds. So the impulse is a vector. So the next is, what's the impulse applied? Find the applied force. So remember, the equation that we're looking for is that the total impulse, which is minus sigma p. Sorry, this is a mistake. It's supposed to be after. So our impulse is after. Did I do after? Yeah, I did. Or final minus initial if you want. That is equal to the average force applied times an interval of time delta t. So we're solving for here. So the average force is going to be the impulse divisible by delta t. So our impulse happens to be minus plus j hat of 0.17, all divisible by the interaction time was 37 milliseconds. 37 times 10 to the minus 3 seconds. So the total force we can calculate as 0.20 divisible by 37 exponent to the 3 minus. So in the I direction we get minus 5.4. In the j direction we get 0.17 divisible by 37 exponent to the 3 minus 4.6. Standard units are going to be in newtons. So the applied force of the wall acting on the ball is 5.4 newtons in the x direction and 4.6 newtons in the y direction.